Hello, welcome to Chapter 4.4, Part 2, Addition, Subtraction, Multiplication, and Division of Inequalities. Addition and subtraction examples. So in example 2, we're asked to solve x minus 4 is greater than 7. So what we want to do is we want to solve for x. And as usual, we're going to do this in the usual way, assuming there is no inequality. So we're going to do the algebra exactly the same way we would do a normal algebraic example. So we're going to add 4 on both sides of the inequality, and we end up with x is greater than 11. In interval notation, this would be the round brackets, 2 round brackets, because as we see, there is no line or equality under the greater than sign. And infinity, it's positive, so we put it on this side, and the 11 we put here, and we put them both in round brackets. In set builder notation, we write curly bracket x where 11 is less than x, or we can write curly bracket x is greater than 11. Either way is fine. Note that the x is on the bigger side of the inequality. That means the x is going to get bigger and bigger. To graph this, we graph this in the following way. Here we have the round bracket to represent that it is open, meaning it does not include 11, and we put the arrow going towards the right because we see it's going to get bigger and bigger. In example number 3, we're asked to solve 3x is less than or equal to 2x plus 5. First, what we want to do is we want to solve for x in the usual way. So we subtract 2x from each side, and we end up with x is less than or equal to 5. In interval notation, since x is going to get smaller and smaller and smaller forever and ever and ever, we put negative infinity here. And we close that side with a round bracket because it'll approach negative infinity, but it will never actually get there. We put the 5 here, but because we include 5, because we have this little line here, which is the equality, we put a square bracket on this side. In set builder notation, we write this as curly bracket x where x is less than or equal to 5, and we close the curly bracket. To graph this, we put the square bracket at the 5, but since the x is getting smaller and smaller and smaller, we place the arrow going left. Multiplication and division properties. If c is greater than 0, the inequalities a greater than b, ac greater than bc, and a over c greater than b over c have the same solution set. But if c is less than 0, meaning it's negative, the inequalities a greater than b becomes ac less than bc, and a over c is less than b over c. These then have the same solution set. In example number 4, we're asked to solve 4x is less than or equal to 12. So we divide by 4 to get x is less than or equal to 3. 4 is greater than 0, so the inequality sign remains the same. And we graph it in the following way because it's less than or equal to, that means we use a square bracket here at 4, and because it's getting smaller and smaller and smaller, our arrow points to the left. We write this in interval notation because it's going to the left and gets smaller and smaller. That means it's going to negative infinity. So we start with a round bracket, negative infinity. And because it includes 3, we put 3 with a square bracket at the end. In set builder notation, we write this as curly bracket x, where x is less than or equal to 3, and close the curly bracket. And this is the graph for x less than or equal to 3. In example number 5, we're asked to solve negative 1 over 3x is greater than 4. For this example, we'll work this one out on the whiteboard. In example number 5, we have negative 1/3 x is greater than 4. So what I'm going to do is I'm going to use the ratio method, because in general we start out doing the example using just regular algebraic techniques. So I'm going to say that negative 1/3 x is greater than 4 over 1. And then what I'm going to do is I'm going to cross multiply. So I'm going to get negative 1x is greater than 3 times 4. Now, where this is negative 1x is greater than 12. But the issue comes up here because now we're not finished, because we don't have positive x. We have negative x. So we have to divide each side by negative 1. And whenever we divide anything by a negative number and we have an inequality, we must change the direction of the inequality. So negative over negative is a positive x, but this is going to become less than, and then positive 12 over negative 1, negative 12. Reviewing what we just did on the whiteboard, we multiplied by negative 3 and we got x is less than negative 12. Now let's graph this. So we see that because we don't have the little line here or the equality sign, we have to use a round bracket. And since x is on the tip of the arrow, that means x is getting smaller and smaller, and that means we have to draw the arrow to the left, which means negative infinity. If we write this in interval notation, that means we start out with a round bracket for the negative infinity, and then we have negative 12, but negative 12 is closed by a round bracket since we do not have the little line or equality sign here. In set builder notation, we write curly bracket x, where x is less than negative 12, close the curly brackets. Remember, since we divided by a negative number, the inequality sign changes. That means that we started out with the inequality sign this way, but because we divided by a negative number, it then turns this way. In example number 6, we have 3x plus 3 is less than 2x minus 1. So let us go over to the whiteboard and work this one out. In example number 6, we have 3x plus 3 is less than 2x minus 1. So I'm going to bring the 3x here, minus 3x.
And so I end up with 3 is less than negative 1x minus 1. I'll bring over the 1 here, and I'll end up with 4 is less than negative x. Now, again, we're not done here. And the reason we are not done is because we have a negative x. And as mentioned earlier, whenever, in order to get rid of the negative x, I have to divide both sides by negative 1. And in this case, whenever you have an inequality and you're dividing by a negative number, what happens is, so you have 4 over negative 1 is negative 4. The direction of the inequality changes, so that becomes, and then you have a positive x. So negative 4 is greater than x, because you must change the direction of the inequality due to the fact that you're dividing by a negative number.
Reviewing what we just did on the whiteboard, we put the variables on one side and the constants on the other side like a regular algebraic problem. So here we go, solving this as though it's a regular algebraic problem. We get 4 is less than negative x. Notice how the direction of the inequality changes because we divide by negative 1 to solve for x. We graph this as follows. Here we have the x on the tip of the arrow here. So that means it's going to get smaller and smaller and approach negative infinity. And since we do not have the little line here, meaning that does not include the equality, that means negative 4 is not included, so we have to make this as a round bracket. We write this in interval notation, starting with the negative infinity, round bracket, negative 4, closing with a round bracket because it does not include negative 4. Or we write it in set builder notation, curly bracket x, where x is less than negative 4, close the curly bracket. In example number 7, we're asked to solve x plus 5 is less than 9x plus 1. So let's go over to the whiteboard and work this one out.
In number 7, we have x plus 5 is less than 9x plus 1. Well, again, we're just going to solve this like a regular algebraic equation, negative 5, negative 5. And then so I have x is less than 9x plus 4, minus 4, minus 4. And then I have negative 9x, and that means I'll have negative 8x is less than negative 4. Uh-oh, issue comes up here because, again, I'm dividing by a negative number. So it doesn't matter what negative number I'm dividing by. The fact that I'm dividing by a negative number says that I absolutely must change the direction of the inequality. So in this case, I'll get negative 8 over negative 8. That'll give me positive x, because negative 8 over negative 8 is 1. And then is greater than negative 4 over 8. Well, that's going to give me positive 4 over 8. And that's the same thing as saying 4 over 8, if we reduce it, is 1/2. Now you can say, well, of course, you can avoid dividing by the negative number if I do the problem a little bit different. So, of course, I can take the example, x plus 5 is less than 9x plus 1. And instead I'll bring negative x, and that means that I will have 5 is less than positive 8x plus 1 minus 1 minus 1. 4 is less than 8x. Divide by 8, divide by 8. So this implies, and here I don't do anything to the inequality because I'm dividing by a positive number, and a positive number, you just leave the inequality alone. So that will give me 4 over 8 is less than x. And of course, if we reduce, 1/2 is less than x. And as you see, these two are the same, because the x, as you see, is on the big side of the arrow in both cases. Even though they're written in the opposite directions, they're still, the x is on the big side of the arrow here, the x is on the big side of the arrow here, and the 1/2 is on the point in both cases, so therefore they're exactly the same answers.
Reviewing what we just did on the whiteboard, we subtract 9x from both sides, subtract 5 from both sides, and we end up with negative 8x is less than negative 4. Divide both sides by negative 8 and simplify. Inequality sign changes because of division by a negative number. In interval notation, we write this as round bracket, 1/2, positive infinity, close the round bracket. We know that it's positive infinity because x is on the broad side of the inequality sign. So we write the positive infinity here, and we close that with a round bracket. Or we can write this in set builder notation, curly bracket x, where x 1/2 is less than x, close curly bracket, or x, where x is greater than 1/2, close the curly bracket. Notice that even though I say less than and greater than, the x is always on the broad side of the inequality sign, which means that it's always going to be getting bigger and bigger. That is why when we graph it, we see that the arrow is going to be pointing to the right, which means it's going to be getting bigger and bigger. And since we do not include the 1/2, because there's no little equality sign under our inequality sign, meaning that little line, we put a round bracket here at 1/2. And as mentioned, since x is getting bigger and bigger and bigger, the arrow is pointing to the right, which means positive infinity. In example number 8, we're asked to solve and graph this inequality. So let us go over to the whiteboard and work this one out.
In example number 8, we have 3x minus 1 plus 2x is less than 6x plus 3. And of course, as I said before, you're going to just solve this like a regular algebraic equation, except at the very end, you're going to look at whether you're dividing by a positive or negative number, and that will help you decide whether you keep the direction of the inequality the same, that means positive, or the direction of the inequality changes, that means negative. So we have 3x minus 3 plus 2x is less than 6x plus 3. And then we bring these two together, 5x. And so that's going to be minus 3 is less than 6x plus 3 minus 6x minus 6x. And that's going to be minus x minus 3 is less than plus 3. So then we have plus 3 plus 3. And that leaves we have negative x is less than plus 6. And of course I could have solved it by avoiding the negative, but because I want to always make this point about dividing by a negative number, that's what makes inequalities unique. I did it this way. So I'm going to divide by a negative 1 on this side and negative 1 on this side. And this implies that we get x is greater than negative 6. So you see how the direction of the inequality changes. So, but of course, as I said earlier, we could have avoided that. Instead of bringing the negative 6 over there, we would have brought negative 5 over here and then ended up with all positive numbers, and we wouldn't have had to worry about changing the direction of the inequality. So the only time the direction of the inequality changes is when you're dividing by a negative number.
Reviewing what we just did on the whiteboard, we distribute the 3 to get 3x minus 3 plus 2x is less than 6x plus 3. We combine like terms to get 5x minus 3 is less than 6x plus 3. We continue to solve like a regular algebraic equation until we divide. And here we have the situation where negative x is less than positive 6. The inequality sign changes because of division by the negative number. In this case, it's negative 1. So x is greater than negative 6. The solution set as a graph is, because of the open interval, we don't have the equality, so it's a round bracket. X is on the bigger side of the inequality, so that means it's going to positive infinity. So here we have the round bracket, and the arrow is pointing right to represent positive infinity. In interval notation, we write round bracket, negative 6, positive infinity, closes a round bracket, or in set builder notation, we write curly bracket x, where negative 6 is less than x, and then we close with a curly bracket. In example number 9, we're asked to solve this inequality, so let us go over to the whiteboard and see what happens.
In number 9, we have 4x minus 3 is less than 2, 2x minus 5. And of course we distribute on both sides, so we get 4x minus 12 on this side, and then we get 4x minus 10 on this side. Well, we see negative 4x, that these x's cancel out, and left with negative 12 is less than negative 10. But this is always true. So therefore, there are infinite solutions.
Reviewing what we did on the whiteboard, we found that when we tried to solve this inequality, that negative 12 is less than negative 10, and this is always true because negative 12 is less than negative 10, and that means that this is always true for all real numbers. So in this case, when we graph it, we can just fill in the number line with the arrows going in both positive and negative infinity for all numbers. And in interval notation, we can write this as round bracket, negative infinity, infinity, closed by a round bracket, because it just goes on and on forever on both sides. Or in set builder notation, curly bracket x, where negative infinity is less than x, which is less than positive infinity. In example number 10, we're asked to solve this inequality. So let us go over to the whiteboard and see what happens here.
In example number 10, we have 2 times 3x plus 5 is greater than 6x minus 1 plus 17. So again, we'll use the distributive law, 6x plus 10, because we're just distributing that there. 6x minus 6 plus 17. And then we'll combine 6x plus 10 is greater than, we're going to combine these two, 6x plus 11. And here again, the 6x's, we cancel these out, and we get 10 is greater than 11. But this is false. And this is always false. So that means there are no solutions.
In reviewing what we just did on the whiteboard, we found that just by doing the regular algebra, we got 10 is greater than 11. But this is never true. This is not true. It's false. And it's always false. Therefore, there are no solutions. So no values of x work. Therefore, the number line becomes a blank line, and you cannot write anything in either interval or set builder notation. In example number 11, we're asked to solve this inequality. So let us go over to the whiteboard and work this one out.
In example number 11, we have 4 over 5, x minus 2 is greater than or equal to 3 over 5, x plus 4. And what I'm going to do is I'm going to move the 3 over 5, x here, because you'll see why in a minute. So I end up with 4 over 5x, 4 over 5, my x minus 3 over 5x minus 2 is greater than or equal to 4. And what I can do is I can now pull out the x. So I have 4 over 5 minus 3 over 5. And I put the x over there. Minus 2 is greater than or equal to 4. Now I can do, you notice how both these denominators are the same? So actually subtracting those fractions is very, very easy because we have the denominators exactly the same. We don't have to worry about lowest common denominators. So 4 minus 3, so that means we end up with 1 over 5x. And then carry everything else out. Minus 2 is greater than or equal to 4. So then I go plus 2, plus 2. So then I end up with x over 5 is greater than or equal to 6. But I'm not finished yet. So what I'm going to do, I'll use the ratio method. So I'll cross multiply. So I'll end up with x is greater than or equal to 5 times 6, and that means x is greater than or equal to 30. Notice I'm only using positive numbers here. There's no issues with the inequality because we're not dividing by any negative numbers.
Reviewing what we just did on the whiteboard, we found that if we subtract 3 over 5y from both sides, we get 1 over 5x is greater than or equal to 6. We add 2 to both sides, and we get x is greater than or equal to 30 by multiplying both sides by 5. Our solution set based in the number line, well, we see that we have the inequality with a line underneath. That means it starts out with a square bracket. We see that the x is on the big side of the inequality sign, so that means that the x is going to get bigger and bigger and go to positive infinity. So the arrow must go to the right. If we write this in interval notation, we start out with the square bracket of 30 because we have the little line here, which means that it will include 30, and then we close it with infinity because it's going to positive infinity, and we close that with a round bracket, or we write it in set builder notation as curly bracket x, where 30 is less than or equal to x, and close the curly bracket. In example number 12, we're asked to solve this inequality. So let us go over to the whiteboard and work this one out.
So in example number 12, I have 2x plus 1 divided by 3 is greater than x minus 2 divided by 2. So because I have this set up as a ratio with an inequality, I can just use the algebraic technique of the cross multiplication in order to solve the algebra part and worry about the direction of the inequality at the very end as usual. So I'll end up with 2x plus 1 is greater than 3x minus 2. So here I get 4x plus 2 is greater than 3x minus 6, and minus 3x minus 3x. So I get x plus 2 is greater than negative 6, minus 2 on both sides, and I get x is greater than negative 8. So here I was very, very careful where I didn't have to worry about changing the direction of an inequality because I kept everything positive. Let us go back to the PowerPoint where I actually solved this instead of using the cross multiplication or ratio method. I used the lowest common denominator method on the PowerPoint.
Reviewing what we just did on the whiteboard, I began by rewriting the linear inequality without fractions by multiplying both sides of the inequality by 6, the least common denominator. This means I cleared the fraction. And here we go. So we end up with 4x plus 2 is greater than 3x minus 6. So now we solve the inequality for x. To get x is greater than negative 8. In interval notation, because it's greater than, there's no equality, no little line here, so it's a round bracket, negative 8, and x is on the bigger side of the inequality. That means it's getting bigger and bigger and bigger, so that means it's positive infinity, and we close that with a round bracket. Or in set builder notation, curly bracket x, where negative 8 is less than x, close curly bracket. We graph this in the following way. Because it's a round bracket at the negative 8, here we start with the negative 8, and it does not include negative 8. X is getting bigger and bigger and bigger, so the arrow points to the right. Thank you very much. I hope that you enjoyed this video. Be well and take care, and goodbye for now.